Hello everyone, Zareen here, and I'm back with a new type of function today, which is the quartic, and it's a degree 4 polynomial function. So before this, you are now already aware of the linear, quadratic, and the cubic functions that I've covered in my previous sessions. But just to have a quick understanding and comparison of what quartic looks like as compared to that of the other three, and given the fact that it's part of the polynomial function, I think it is important to have a look at all of these graphs which have put up for you. So just a quick note here that the major intention of this session and all these sessions so far and the ones that are going to come up in the next upcoming ones, they are all dedicated to make you understand about how these different graphs look like, how they kind of, are supposed to be taken into consideration in your day-to-day lifestyles. And this is not just for kids, but also for people of any and every domain of every age. So feel free to watch it, share it with your loved ones. And yeah, if you are interested into knowing more about any particular type of graph, I do recommend that you go deep into it. But for this class, we are going to focus on the conceptual overviews because as you grow older, you need to have a consolidated understanding of what different functions are all about, how you're going to integrate them, how you're going to, use it for different purposes. So yeah, a lot of things will come into the picture, but stay tuned for that. And for now, we are going to look at this quartic. It's quartic, Q-U-A-R-T-I-C. It's a degree 4 polynomial. And as you can see, what more to expect? It's a U-shaped type of a graph, but it's not perfectly U-shaped. You see, it's different from the one you're seeing here. For the quadratic one, it's a sharp parabola, right? So when I say a sharp parabola, it means you can expect that here, this kind of a tangent, if you just make, you'll just get a feeling that this particular thing, the curvature of it is different from what you will see here. So if you just kind of happen to draw a tangent here, you can see that it's getting more flattened near the axis. So if you are looking at y equals x to the power 4, this is what you are seeing. And interestingly, because it's an even function, when I say an even function, you can, for the time being, compare it with the quadratic and this quartic. You can compare them together. These are even. There are different definitions of odd and even functions. I'll discuss it in the later classes. But for this one, you see that you can understand that the tails of this kind of concave nature of the graph, it's going up, and that's because it's even, yeah. But if it was odd, like that in a degree 3 kind of a function for cubic function, you'll see that it's not in the same direction, it's in the opposite direction, yeah. So here, so these tails are important here. So I'll cover about the multiplicity part and whether you should be expecting it to, touch and then bounce, and those things will be separately dealt with. But for here, just focus on these two equations right now, y equals x to the power 4 and y equals x to the power 4 minus 4x square. And you can understand that it's a degree 4 polynomial. And well, it looks like y equals ax to the power 4 plus bx cube plus cx square plus dx plus e. And this is not any different from the standard expressions we have been dealing with for linear, quadratic, and cubic types. But this is a degree 4, and the highest power is 4 in here. It's different from the concept of multiplicity because multiplicity has a relationship with roots, and I'll talk about it separately. Okay, so here what you can see is that the quartic 4, we can find about the inflection line, the turning points, the shape, and it's all similar to the ones that we have already discussed. So we are not going to spend more time getting more deeper into this. But for the time being, all you can know about it is that for a quartic degree 4 polynomial, you can expect a kind of a U-type parabolic nature, or something with a W or M-shaped type wiggles contained in it. When I say wiggles, I mean, if you just have a look at this particular part, this particular part. So internally, there can be wiggles within this sort of a graph. And again, yet again, note that this is an even function. Had it been odd, you would have expected something like a cubic type function where it was more of an S shape, but here it's U nature. It can also be opposite to U. So it all depends on whether the tails are pointing like up or whether it's pointing down. So these things are going to be determined by, again, the coefficient of your highest power of X, which in this case is 1 anyway. So because A equals 1, and so it's greater than 0, so therefore, all of these things are pointing up. Had it been the opposite way around, you might have expected that it would have shown something like this. Okay, and then when we talk about the turning points, again, it's the same type of concept. For finding them, you need to go for a differential, and that will be the first order differential. So if you go for a y prime, it will give you certain form of the expression that you would be equating with 0, and you will see what are the results. And from there, you can also find out the roots. The roots will give you another idea. Like, for example, here you can expect some sort of x equals 0 with a multiplicity of 4. I'll be discussing more on that in the next topic. But here, it's more of it's your graph is kind of touching x equals 0 here, and then again it's going on the other way around. It's all affected by the multiplicity part in here. You can also imagine this as x minus 0 whole to the power 4. And that's why your root is like 0, but it's a multiplicity 4 in here. And it's different from degree. And this is going to be our next talking point for the next video. Okay, so these are the basic things. Now, after turning point, usually when you think about inflection points you can find from y double dot, or y double prime, or d2y by dx2, whatever you prefer to call it. It's up to you. And so then when you find y double prime, you will see whether it's less than 0 or whether it's greater than 0. So that can help you to get an idea about the nature of the concavity and stuff. You can see how the concavity is flipping around what and what not. So all these things you can determine from in here. So I recommend that you watch the old videos if you haven't so far. That will give you a gross understanding of what to expect next. Now, as we are proceeding towards the end of the polynomial functions, its polynomial function can have higher degree orders. It can be ranging from 1, 2, 3, 4, 5, and whatnot. So before ending polynomial functions, there is a short note I would like to add. And if you want to reach out to me and want to share your thoughts, your feedback, your comments, you're most welcome. I'll share a QR code which you can scan, and then you can reach out. This is to maintain certain protocols. So yeah, that's all. Thank you so much, and we'll see you in the next video.